Hi, welcome to Analytics for All. This is going to be a bonus lesson in our Python for Data Science course. This lesson is going to be on closures. I actually received a request via YouTube to make a video on closures and decorators. And after thinking about it, I really can't make one video. I've decided to make two. Even though they are interrelated, I really think it's better to make two. I want to start off by saying this is kind of an advanced topic. It's a very computer science-y related topic. This gets into things like memory and performance. But instead of trying to throw out definitions that don't make a lot of sense, let's go ahead and just get into it and take a look, and we'll work from there. Now, as with all my lessons, I do have a write-up on my website, analyticsforall.org. I will put a link down in the description. You can get to it. But let's jump over to my Jupyter Notebook, and we'll kind of get into it. I'm going to zoom in. All right, now, to understand closures, the first thing we got to get into is nested loops, the idea of a nested loop. That's the idea of putting not loop, I'm sorry, nested function. And that's the idea of putting a function inside of another function. Okay? So in here, just really quick, take a look here. We've got a function called outer function, which takes in a single argument x. And now we have a function called inner function, and it prints this argument x inside the inner function. And then at the end, we just call the inner function. And I know this is the longest way possible you could just print hello world, but if we call now the outer function, I'm going to push hello world to x. X is going to pass through to the inner function because the x is inside this function, so it's inside this environment. You might hear about, like, if you look into some computer science books, you'll see things like, hidden variables and, hiding stuff between parts of the program. This is kind of it, but I'm really not going to worry too much about that. Just understand that this x, the inner function can see the x because the inner function is inside the outer function. If the inner function happened to be a separate function, like if instead the inner function was out here, it would not be able to see that x. In fact, I'll do it next just to show you here. Let's go ahead, let's run this real quick and show you. See, that gets the hello world, so it's able to print. Again, I said this is the most roundabout way to print hello world possible, but I'm trying to make a point here. All right, so like I say, let's go ahead and do it this way. Let's go ahead and take our inner function out here. And, if I try calling the inner function from here, we'll see what it's not going to work. Okay, bunch of errors. They don't see each other. They don't talk that way. So the only reason, just what you need to know, is the only reason this inner function is able to print x because it's nested inside this outer function. And that's the main thing we want to worry about right now is nesting. All right, so now we're actually going to create our first closure. Okay, now I'm going to go ahead, I'm going to just, so we can see better, I'm going to go ahead and delete this. All right, so let's take a look at these two things. They look very similar, right? Big difference sits right here. This is what makes it a closure. Okay, so what we have here is, instead of just calling the inner function like we did inside here, we're returning the inner function. But notice this. Notice the parentheses are missing. You know, that's a big sign. That's where we got a closure now. Okay, so now I'm going to pass the outer function hello world to a variable and then call the variable as a function, because so notice I don't need to put anything in the variable function because it's got the hello world coming to it. I send this, and there it is. So it works hello world because I passed this with the argument in it to a variable, then just called it as a blank function. It works. All right, you're thinking, okay, who cares? All right, so first of all, let's go down here. I want you to see this. It's a function. This variable is a function. Notice when I say to print the variable, it returns an outer function, inner function. It tells me what it is. So it lets me know about the function. So that's what that var is. It's not just this var is not holding hello world. This var is holding the function. Okay. So how might this be at all of interest? Okay, so check this out. The cool thing about a closure is it's going to save, once you've assigned this, it saves this value in there. So watch this. I can delete the outer function. That's what this command does. And I'm going to try to call it now with help. So if it works still, it should just return help as a print, right? No, returns an error. Okay, outer function's not defined. That's another word meaning outer function's gone. But watch this. When I go here and I hit the variable, I get hello world, which means even though this function's been deleted, this no longer exists in our program, I'm still able to call this instance of the function we called. And that's, I think, is really the selling point of closures here at this point. So I want to get some space down here so we can talk about this. But, oops, put these down. This one down. Hold on. I'm formatting so we can see better. Okay. All right. So that's kind of the beauty. I'm gonna look at a real example here, and we'll explain why this is important and why the closure is important versus just. I mean, because I know this looks like an awful lot of work just to print hello world. All right. So let's go ahead and look at a somewhat real world example. So I have now a function called multiply by with an x and a function called value with a y. And it's going to return, and it's notice nested inner, it's going to return x times y. And it will return a value out here. Okay. Notice value is this, so I got no parentheses at the end, so I have a closure. All right, so let's start by, we're going to create a variable or a function. We're writing a function. Remember, this is a function. If we go and print this, it's a function. So we're going to create a function called double by passing it mult by 2. Okay? So that's actually feeding x. So now now when I go to print the double and I send 2, well, this 2 is going to y. What do you think is going to happen? Well, we're going to get 4 out because this double now knows that every time it gets called, the first variable is x, and it's going to store that forever. It's not, And notice we can do it here with the print 3, print 4. Okay. And notice I can go down here and do a triple. So I can change the first value to 3. So now I look at triple times 3 and double 3. So what do I get? 9 and 6. Okay, cool. So that's a closure. And why do we care about this closure? Well, the cool thing is what's happening is imagine I have a calculation up here that's a bit more complicated than just an X. Imagine I'm doing like a search against millions of records. Either a very complex mathematical calculation or I want to feed 100 million records through this. Well, which in data science, that happens all the time. 100 million. I work with billions of records sometimes. I deal with calls out of Verizon. It's a lot of stuff coming through. So if the fact that it already stores half the equation up here, it already stores part of it, it already stores the part 2, it's got that already, it doesn't have to pass that each time. I mean, that can save, a tenth of a microsecond off of your, equation, off the runtime. I mean, so if it saves a microsecond, which, blink of an eye, we would never see this. I mean, microsecond is a millionth of a second here, so it's this many behind it. But, like I said, I'm doing a billion records. How that phone thing came up, that was kind of cool. So I'm saving 100 seconds on something like that, which, this can add up. This is where a closure comes in. Hold on, I'm not sure I'm saying that. So I say, that's the big thing about closures. So in small programs, not a really big thing. In large programs with heavy calculations, or if you're using lots and lots of, sending lots and lots of stuff to it, this is where a closure will come in handy. So the main things you want to take away here is to keep in mind that a closure is a nested function. Okay, you'll notice it by a return of the inner function without, there's no parentheses, no parentheses. And the main things, the main reasons we care about this, the main thing we want to do is we want to improve either performance of the CPU, of the calculations, performance of CPUs, or improve memory. Because the fact that if you went up here, remember when we tried this var, even though we deleted the outer function, it still saved it in there. So it'll store just parts of the memory. So it's more efficient in memory and in speed. But again, when you're writing small programs, it's not much use. But when you're in big programs, a lot of stuff, this is where closures will come in. Okay, I'm going to go into the next lesson with decorators, and we'll go into that, and hopefully we can clear some of this up. Thanks a lot. Again, thanks. Go ahead and visit my site, analyticsforall.org. I will have the link in the description. Go ahead and hit the like, subscribe. Let me know if there's anything else you want me to do. Clearly, this video and the next video are a direct result of somebody asking a request in my YouTube videos, and I will try to make videos if you ask me to do them. Again, thank you very much.